title of the first section is Domain and Range. Two definitions: domain. Domain is x values. And second definition, range. Range are the y values. So when looking at a graph or a list of numbers, the domain will be all the x values and the range will be all the y values. First problem is a t-table or xy chart. The x values are 1, 2, and 3, and the y values are 4, -5, and 7. Looking at the t-chart or the table, we can determine the domain and also the range. Domain is a list of the x values. X values in this case are 1, 2, 3, so the domain would be 1, 2, 3. And likewise the range, the y values are 4, -5, and 7, so the range would be 4, -5, and 7. Second question is a graph on the xy axis. We'll go out to 3 in each direction. The first point is at -1, -1. The second point is at -1, +2. And the third and final point is at 3, +1. So in this problem we have 3 points on a xy axis. From this graph we can determine the domain and also the range. The domain again is the x values. Looking at the first point that we had, the x value was -1. The second point we had, the x value was also -1. Since we have it listed once, we don't have to list -1 twice. And the last point, x value we had was 3. So the domain would be -1 and 3. Likewise the range, the first point, the y value was -1. The second point, y value was 2. And the third point, the y value was +1. So our final answers: domain is -1 and 3. The range is -1, 2, and 1. Third question and last question for the section. Again, is a xy axis graph. We'll go out to 2 in each direction. One point on the graph is at 0, -2. And this point will be the vertex of a parabola that opens up. The parabola curves up to the right and also curves up to the left. So this is a graph of a parabola that has a vertex at 0, -2. From this graph we can find the domain and also the range. The domain again is all the x values. Looking at this graph, the line consists of many or infinite points. All those points contain any x value on the graph. You can take any number on the graph negative. If you go up high enough, the graph will go up to that point and the x value will be on the graph. Same thing for any positive value. If you go up high enough, any positive value will also be on the graph. So since every x value, positive and negative, is on the graph, the domain will be all real numbers. all real numbers again, because every x value is on the graph. For the range, if we look at the y values, every positive y value is on the graph. Again, if the graph continues up high enough, any positive y value we can find on the graph. For negative y values, if you look for the lowest point would be the vertex on this parabola that curves around at the y value of -2. There are no numbers less than -2 that are on this graph. So the range has to be -2 or bigger, or the range y has to be greater than or equal to -2. So again, the domain, every x number is on the graph, so it's all real numbers. And the range, the smallest y value is -2, so all y values have to be greater than or equal to -2. Title of this section, is it a function, and is it discrete or continuous? The first definition is 1-to-1. 1-to-1 states only one x value for every y value. What that means is every x value can only have a single y value. If you have the same x value listed twice, but the same x value has different y values, then it is not 1-to-1. Second definition, vertical line test. Definition is passes only one point. If a graph is drawn, you can draw a vertical line through any part of the graph. A vertical line goes straight up and down. If it passes only one point, then it passes the vertical line test and it's a function. If it does not pass the vertical line test, which means it goes through 2 or more points, then it does not pass the vertical line test and it is not a function. The next definition, discrete. Discrete is a set of points. Looking at a table or a graph, if you can count up how many points there are, then it is discrete. Continuous, if you have a line or curve, there's an infinite number of points on every line and every curve. An infinite number of points means it's continuous. First problem for this section is a t-table or xy chart. The x values are 1, 2, and 3, and the y values are 4, 5, and 6. The two questions we'll answer: is it a function, and is it discrete or continuous? Looking at a table of values, we can use the 1-to-1 definition. 1-to-1 means every x has a single y. In this case, all the x's are different. Anytime you have all different x values, it is automatically a function. The second question, is it discrete or continuous? Looking at a table of values, there's 3 points, 1, 4, 2, 5, and 3, 6. There are 3 points in this graph, or a set of points, which will make it discrete. Anytime you can count up the number of points, it would be a discrete. Second question, another xy t-chart. The x values in this case are -1, 0, and -1. And the y values are 5, 10, and 15. When using the 1-to-1 definition, you want to look for x values that repeat. In this case, we have -1 that repeats. 1-to-1 means every x value has one y value. In this case, -1 has a y value of 5, and -1 also has a y value of 15. So if you have the same x value and they go to two different y values, that makes it not one-to-one or not a function. If it is not a function, it is neither discrete nor continuous, so the answer would just be not a function. Second question, or third question. Have another t-chart, xy table. Numbers for x are 5, 10, and 5. And the numbers for y are 1, 2, and 1. Again, when looking at a table of values or using the one-to-one definition, one x value has to have every one y value. The x value 5 repeats. 5 has a value of 1, and 5 also has a y value of 1. Having the same point means they go to the same y value, which is okay. It's still one-to-one and is still a function. So repeating x values, it's not okay to have the different y values, makes it not a function. But if repeating x values have the same y value, it's still a function. Looking at the t-chart or xy table, there's 3 points. If you can count up the number of points, it is always discrete. Fourth question is a graph on a xy axis. This graph starts at 0, 0, and is a parabola that opens up, curves up to the right, and curves up to the left. When you're looking at a graph, you can use the vertical line test. The vertical line test says you can draw any vertical line through the graph, and if it only passes one point every time, it is a function. So in this case, any vertical line you can draw passes one and only 1 point, so it is a function. When looking at a graph of a line, there is an infinite number of points on this line. An infinite number of points, or if you have a graph or a line or a curve, it is continuous. And last problem for the section, again, is a xy graph, and we'll have a circle around the center of the graph. The circle, again, has an infinite number of points around the circle or on the circle. And if we use the one-to-one graph, you can draw a vertical line on the outside, which doesn't pass any points, which is okay. You could draw a tangent line that touches 1 point on the outside of the circle, which is still okay for being a function. But if you draw a line anywhere inside the circle, the vertical line passes 2 points, which makes it not a function. And again, if a graph or t-table is not a function, it is neither continuous nor discrete. Title of the last section today is Evaluate Functions. The first function we'll look at is f of x, which is written f inside parentheses x, which again, if you read out loud, stands for f of x, equals x squared minus 5. This means the function of x is equal to x squared minus 5. First problem we'll solve using this function is f of 5, or f inside parentheses 5. What we'll do for the function is 5 will be the number that we'll put in place of x that we'll use inside the function. So instead of x squared minus 5, we'll plug a 5 in, and we'll have 5 squared minus 5. 5 squared is 25, minus 5 would be 20. So the value of f of 5 is equal to 20. Second question, f of negative 2, or again f with negative 2 inside parentheses. Using the same function we had before, x squared minus 5, we'll take a negative 2 and plug it in for x. Negative 2 to the second power minus 5. Solving this one, negative 2 squared would be 4. 4 minus 5 would be negative 1. So f of negative 2 is equal to negative 1. And the last question for the section, f of 2a, or the function of 2a. In this question we'll take 2a and plug it in for x in the original function. Instead of x squared, we'll have 2a to the second power, or squared, and then minus 5. 2a inside parentheses squared. The squared gets distributed or goes to each number in each variable inside. So 2 squared would be 4, and a squared would be a squared. Minus 5 would come down. This question cannot be simplified. There's no like terms. So the final answer, the value of f of 2a, is 4a squared minus 5. Title of the first section today is Find the Slope of 2 points. Using 2 points, we can find the slope between the 2 points. The definition or equation for the section, m will stand for slope, and the equation will be y2 minus y1 divided by x2 minus x1. To find the slope of 2 points, we will subtract the y values in order, and underneath on the denominator of a fraction, we'll subtract the x values in order. First question. First point is 4 comma negative 1. And the second point is 6, negative 6. When using the equations above, the 2 means it comes from the second point, and the 1 means it comes from the first point. So the slope for this question, y2, would be the second y value from the second point, which is negative 6, minus the first y value from the first point, which is a negative 1. Divided by x2, the x value in the second point, which is 6, minus the x value in the first point, which is 4. Solving from here, negative 6 minus a negative 1. Whenever you have minus minus or two negatives, we can change that to positive. Negative 6 plus 1 would be negative 5. and 6 minus 4 would be 2. So the slope would be negative 5 over 2. Second question. First point is 2 comma 6 and negative 3 comma 6. And again, using the equation from above, the slope, m equals the second y value, which is 6, minus the first y value, which is also 6, divided by the second x value, which is negative 3, minus the first x value, which is 2. Subtracting 6 minus 6 would be 0. Negative 3 minus 2 would be negative 5. And 0 divided by any number would be 0. So these 2 points would have 0 slope, which also means it's a straight horizontal line. And the last question for the section. The first point, negative 1 comma 3 and negative 1 comma 5. M equals the second point y value, which is 5, minus the y value from the first point, which is 3, divided by the second x value, negative 1, minus the x value from the first point, which is also negative 1. Subtracting 5 minus 3 would be 2. 1 minus a negative 1. Minus minus, or 2 negatives again, we can change to addition. So negative 1 plus 1 would be 0. For this question, 2 divided by 0, or any number divided by 0, the answer would be undefined. It is impossible to divide any number by 0. So the slope would be undefined, or in terms of graph, the line would be a vertical line straight up and down. Title of the next section is Graphing a line using a point and slope. In this section, we'll graph a line using a point and a slope. First question, the point is negative 3 comma negative 1, and m equals, or the slope equals, 1 over 5, or 1/5. Using a point and a slope, we can draw the graph by drawing the xy axis. We'll start with the point first, negative 3 comma negative 1. The x value is negative 3. The y value is negative 1. So the negative 3, negative 1 would be the point. The slope, 1 over 5. The numerator, or top number, tells you what the rise is, how much the number goes up. And the denominator, in this case 5, tells you how much the run is, or how much to go to the right. So from this point, we'll go up 1 and 5 spots to the right. Up 1 spot would be on the x-axis, and 5 spots to the right would be at positive 2 for the x-axis. So going up 1 spot over 5 spots, we can connect the 2 points, and we have the graph of the line. Second question for the section is the point 3, negative 4. And we'll use the slope, or m equals 2. Again, we can draw the graph for the xy axis. The point 3, negative 4 x value would be 3, the y value would be -4. For the slope of 2, anytime the slope is an integer or whole number, you can make the slope a fraction by putting a 1 for the denominator. And again, like the previous problem, we'll go up 2 and to the right 1. From the point we graphed, up 2 spots and to the right 1. Taking the 2 points, we can connect it to make a straight line. And that would be the graph for the question. And last problem, the point is -2, -3, and m equals undefined. Again, having a point and a slope, even if the slope is undefined, we can draw a graph for the question. Drawing the point -2 and -3. If you think about the previous problems, what we did that were undefined, undefined means you have some number in the numerator and 0 is always in the denominator. It does not matter what number is on top, but 0 for the denominator would be undefined. That means we go to the right 0 spots, or do not go to the right, and the number means we can go however many spots we want up. In this case, you could just go 1 spot up, or again, however many spots you want to go up, but it does not go to the right. So the line would be a straight vertical line going up and down anytime you have a undefined slope. Title of the next section is Are the following parallel, perpendicular, or neither? Two definitions. Parallel, when you have parallel lines, you have to have the exact same slope for both lines. When you have perpendicular lines have to have the opposite reciprocal slope. Opposite meaning one is positive, one is negative, and reciprocal meaning it's the same fraction but flipped upside down. First question we'll look at is y equals 3x minus 2. And the second equation for the same problem, y equals 3x plus 2. Looking at these two equations, we can figure out if they're parallel, perpendicular, or neither. If you remember from Algebra 1, y equals mx plus b is the equation for a slope-intercept form. The m is a slope, so the number in front of x will be the slope. In this case, we have 3x and 3x. So the slope in the first equation is equal to 3. The slope in the second equation also equals 3. Since both the slopes have the same value or same number, these are parallel. Second question is a graph on a xy axis. One line and the second line. Looking at these two lines, we can decide if they look parallel, if they look perpendicular, or if they are neither. Parallel lines would be lines that go parallel side by side that do not cross. Since these cross, they're not parallel. Perpendicular lines, when they cross, they make a 90-degree or right angle. This is not a 90-degree or right angle. So if it's not parallel, not perpendicular, these lines would be neither. So it's not parallel or not or perpendicular.